To find the derivative of x to the third times the quantity of 5x minus 4 to the sixth power, we're going to have to use the product rule and the chain rule. This is a product because we have a factor of x to the third and a factor of 5x minus 4 to the sixth power. And the chain rule will have to be used when we differentiate the second factor, 5x minus 4 to the sixth power. Let's get started. The derivative, using the product rule, is the first factor unchanged, x to the third in this case, times the derivative of the second factor, which I said was 5x minus 4 to the sixth power. The derivative of this factor requires the chain rule. It's a quantity to a power. We'll use the general power rule and write its derivative as 6 times the quantity of 5x minus 4 to the fifth power, but then we have to multiply by the derivative of 5x minus 4, which is 5. So this is, using the product rule, the first factor, x to the third unchanged, times the derivative of the second factor, which turns out to be 6 times 5x minus 4 to the fifth times 5. The second part of the product rule is the second factor, 5x minus 4 to the sixth, unchanged, times the derivative of the first factor, and the derivative of x to the third is simply 3x squared. So we have a derivative, but let's clean this up. In the first term, we have 6 times 5, which is 30, x to the third, times the quantity of 5x minus 4 to the fifth. And the second term is 3x squared times 5x minus 4 to the sixth. There's some common factors between these two terms. Between 30 and 3, there's a common factor of 3, and between x to the third and x to the second, there's a common factor of x to the second. Because when the same factor is included in both terms, the lower power is factored out to the front. And we're going to use that same idea when we take a look at 5x minus 4 to the fifth and 5x minus 4 to the sixth. It's exactly the same factor, 5x minus 4, so we can factor it out to the front, taking the smaller power, 5, between 5 and 6. So 3x squared times the quantity of 5x minus 4 is the common factor that has been factored out to the front. What we're left with after we factor this, well, from 30x to the third, 10x to the first power, and from 5x minus 4 to the fifth power, well, that's been factored out to the front completely. So all we're left with in the first term after factoring the common factor out to the front is 10x. If you think about distributing 3x squared times 5x minus 4 to the fifth power into the brackets, you would end up with what you started with in the first term. Let's look at the second term. If we factor 3x squared times 5x minus 4 to the fifth out to the front, the 3x squared has already been factored out to the front, and we have 5x minus 4 to the sixth power, but we factored 5x minus 4 to the fifth power to the front, so we're left with just 5x minus 4 to the first power. One step left in the simplification process. I'm going to copy down the common factor that I brought out to the front, unchanged. And then inside this bracket, I have 10x plus 5x minus 4 to the first. 10x plus 5x minus 4 is 15x minus 4 after combining the like terms. So the derivative in factored form of x to the third times 5x minus 4 to the sixth power is 3x squared times 5x minus 4 to the fifth times 15x minus 4.